Hello class, welcome to the last section of our studies on linear equation and inequalities. And this is one of the most interesting part of this particular studies, linear programming. This time we are going to work on a graphical approach to real-life optimization problems. What is linear programming? Linear programming is a method of finding the maximum or minimum value of a linear function, and this is subject to a set of linear inequalities. So the inequalities that we are going to be subjected to is the one that we call the constraint, the limit. We've already studied the graphical solution of systems of linear inequalities, and we were given some inequalities to find their solution or the satisfied solution. So these inequalities given are the ones that we term as the set of linear inequalities in the form of constraint format. So that inequalities that we got to know are the constraint, they are the limit. And we use this in real life for profit maximization or cost minimization. That is an example. And before we can understand this concept very well, then it means that we need to get this key concept in our mind. Linear programming deals with objective function. So what is your objective? What do you aim at? So the objective function represents the expression to optimize. So optimization simply means finding the efficient way of solving a problem, whether to maximize your the profit, example, or to minimize the cost, the example that we've just read. So if we talk about optimization, it means we are going to find the best way to solve problem or the best solution to increase our profits or to reduce the cost. Good. So here the next thing to understand is the constraint. The constraints are the limitations or the conditions attached to the expression or the problem. So we need to know that the problem have constraint, have limit to a certain point. So those limits or those conditions are what we call the constraint for that particular problem. And we also have to know what we call feasible region. So the feasible region are the regions that satisfy the inequalities. And these regions contains points that makes the inequalities acceptable. So the feasible regions are the area where all inequalities overlap. It means that at that point, at that region, any point that you are going to take and substitute into each of the respective inequalities, you are going to end up with as an acceptable results or answers. Then there is also one important aspect that we need to put in mind, that is the corner point. The corner points are the end points of the shape form, whether it will be in the polygon shape, any kind of geometric shape. So the endpoints form from the intersections of the lines that we've drawn or that you've drawn. The point of intersection of the lines form a shape. So that endpoints are the ones that we call the corner points. And it is the point on the boundary where optimal values occur. So the optimal values are very sensitive at this particular point. Then let's look at the steps to solve a linear programming problem. If I want to solve a linear programming problem, what are the steps to follow? Step number one, I have to define decision variables clearly. So sometimes the question will be given to you, the problem will be given to you. What are the variables that you are deciding on? So example, maybe we are deciding on X to be tables and Y to be chairs. So it means that the problem was to be on tables and chairs. Then number two, we should write the objective function. The objective function is what we are interested to find, the problem that we are solving, whether to minimize the cost or to maximize the profit. So here we can look at this example. The example here is to maximize the profit, which is equal to AS plus B in a relation form. Then number three is to write the constraint as inequalities. So the limit supposed to be written in the form of inequality expression. So those are the ones that we are going to use to find or to draw our graph to find the best solution for our problem. Then four, we should graph each inequality on the same graph sheet or plane. Then the five is to identify the feasible region, that is the region that satisfies all the inequalities and shade. Then the six is to find all the corner points. So it means that the moment you are done plotting all the inequalities or plotting all the graph or the lines, they are all going to meet at a certain point to form a geometric shape, whether in the form of parabola, square, trapezium, whatever it is, you see a shape. So that shape is what we call the feasible region, which has been shaded. So the end points are the ones that we call the corner point. We are going to take all these points into consideration, and we will substitute all these points into each of the inequalities to see which of them will produce an answer that will solve our problem, whether to maximize the profit or to minimize the cost. So choose the value that gives maximization or the minimization of the problem. So if the point maximize your results and you are looking for the maximization, it means that we choose that point. If it minimizes the results and we are looking for minimization, it means that we have to select or choose that particular point. So these 8 steps are what we need to follow to deal with linear programming problem. Good. So let's see an activity one. A carpenter can make a maximum of 20 tables and 30 chairs per day. Each table requires 3 hours of labor and each chair requires 2 hours of labor. So these ones are the labor time. So the maximum total number of hours of labor time that the carpenter has at his disposal is 96. So first A, we should give 3 inequalities that express the above conditions. Then B, we should graph and shade the common region that satisfy these inequalities. Then C, find the maximum part of chairs and table that can be made within the time at his disposal. So when you look at this one, the variables for us to be able to define this problem or solve this problem, the variable here is table and chair. Then we also have constraints. So the constraint is the limitation. So here a carpenter can make a maximum of 20 tables. So it means when I take variable table, the maximum that I can get for a day is 20. So the table production will not be greater than 20. So it's going to be less than or equal to 20. Then the chair production too is going to be less than or equal to 30. Why? Because the number of production of the chairs cannot be greater than 30 within a day. Then there's another limitation here concerning the time or the hours of labor. Good. So all these things are the limitations that we need to use to write our constraints. So look at it. The solution is here. The X indicate the number of tables produced per day. The Y indicate the number of chairs that the carpenter will be able to produce. What are the constraints? we can only produce 20 tables per day. So it means that the tables will be less than or equal to 20 for a particular day. We can also be able to produce 30 tables as maximum, 30 chairs rather, at maximum per day. So the constraint will be y less than or equal to 30 because the capital cannot produce a chairs rather more than 30. So the maximum can be 30. So it can be 30 and below. Then there is a constraint for the hours of labor. So here we have 3x plus 2y being less than or equal to 96 because when you combine the hours of labor of the production, it's supposed not to be more than 96. It is supposed to be 96 and below. So we have 3 hours of production for a chair, for a table. So that would be x, and 2 hours of production for a chair, that will be y. So it means that when I combine these 2 hours of production, that is 3x plus 2y, where x represents the number of tables produced and y represents the number of chairs produced, my hours of production will be less than or equal to 96 hours. That means it won't exceed 96 hours. So here the labor constraint is 3 hours for table and 2 hours for chair with a total hours of 96. So note, x supposed to be greater than 0 because if you are producing a table per day, there's no way you can produce 0 table per day. So it can be 0, all right. So it might be 0 or more. Here too, the number of chairs to produce can be 0 or more. So what we have to put in mind is we are not going to get negativity here. We are not going to deal with nothing or maybe a negative number here. So what is the problem? What do we want to optimize? We want to optimize the total number of items to produce. We have to increase the number of items to produce. So the P represents the maximization of the items to produce. So the item to produce is I want to produce a maximum number of items, which is x plus y. So x plus y, the number of tables produced, the number of chairs produced. When you combine them, that will be the, you want to know the number of chairs and tables combined that we can produce per day. That is the optimization objective here. So the step 1 is we have all these inequalities. We turn them to equal sign as we used to do in solving graphical solution for the inequalities. Then we plot all these inequalities or this line graph, this line on a graph page like you are seeing here. So we have the red line indicating x less than or equal to 20. We have the green line indicating y less than 30. And we have the blue line indicating 3x plus 2y less than or equal to 96. So you can see all these lines intersect at a certain point. And we have to find a solution for this, a feasible solution for this particular graph. So the feasible solution will be the part that satisfies the inequality. So when you look at it here, there we have the point A, point B, C, D, and E. Those are the corner points, as we said. So this one is a polygon here. So the corner points are the ones that we are going to substitute into the inequalities to see if they satisfy. So this one becomes the feasible solution here. So let's cast our mind back to graphical solution to know how to find the feasible solution. So point A will give us 0 as the day of production. Then point B will give us 30 as the number of items produced per day, because the number of items produced per day is chairs plus tables. So this is the chair, this is the table. When you combine, you get 30 items. Then the point C will also give us 42. Then the point D will give us 38. Then the point E will give us 20 when you combine them. So it means that the point that will give us the maximum number of items produced per day is 42, is the point of 12 and 30. So it means that on a day we can produce a maximum of 12 chairs and 12 tables and 30 chairs. So that is the point that gives us the maximum value, which means that 42 items could be made with 96 hours of labor.